It's another one, guys. This iPhone 11 Pro Max was sent to me by one of my customers. It shut down, it wasn't coming on, and from the image on the screen is bad. You can see the screen is bad, so the screen needs to be replaced. But apart from the screen, the phone is not coming on, it's not powering at all. It's completely dead. It's completely dead. So I connected the power cable to see what's wrong with the board, to see if the reading is normal on the DC power supply, to see if the reading is normal on the DC power supply. So after connecting the power cable, immediately I pressed the power switch, it drew 412 amps, 412 milliamps on the DC supply. So from experience, I already knew that the charging IC is the problem, which is the charging IC 1612 A1 charging IC is the problem. So as you can see, if I click on the power switch once, just click and release it, okay, you are seeing it's drawing too many amps. That is overcurrent, 412 milliamps on the DC supply. So from my experience, I already knew that it's the charging IC that is faulty. So the charging IC is the problem of this iPhone 11 Pro Max. So I'll need to disassemble the board because it uses a sandwich board, up and down layer. So the board is off now, it's off from the frame. So here is the board on the desk. So yeah, that is the board on the desk. So currently you are seeing the upper layer. So it is a sandwich board, it uses a sandwich board 2-in-1. So I'll be using this mechanic heat plate. To separate the upper layer from the lower board. Here is it. So currently I'm trying to set the temperature to, I'll set the temperature to 230 degrees Celsius. 230 degrees Celsius should be enough to separate the board. So usually this kind of faults always arise as a result of fake chargers. Used by customers on their iPhones. Okay, so I always advise my customers to try and get good original chargers. Always try and get good original chargers, because you cannot compare the quality of a 4,000 naira charger to a 15 or 20,000 naira charger. The quality and the build, they are always different. Okay, so this fault I know is as a result of a cheap charger that was used by the user. Okay, so because if you don't buy original chargers, it means you are playing, and when you are playing, you will learn the hard way. And when you learn the hard way, you don't have any option that to come to AB Telecoms to rescue you. And remember, iPhone repairs are not cheap at all. iPhone repairs are not cheap to fix. So this iPhone 11 Pro Max now, apart from the screen that is faulty, the charging IC is bad now, and this charging IC is very expensive to fix. So I want you guys in the comment section to comment how much you think this iPhone 11 Pro Max I charged this customer for this fault to fix this charging IC, let alone the screen. So guys, you can see it. I want to test. I know it's the charging IC. Okay, that is your charging IC 1612 A1. That is the charging IC for 11 Pro Max 1612 A1 charging IC, okay, 1612 A1 charging IC. So I already know from that current, that overcurrent that is drawing so far, when you press the power switch, is the charging IC that is faulty. That is, the charging IC has a short, so it means it's bad, so it need to be replaced. So this is the charging IC, this one. So here is the charging IC that I'm using this speaker to touch now. So this is the charging IC. So I already know from experience, I know it's the charging IC, but I just want to confirm. Not that I want to confirm, I know it's the charging IC, but to my fans and fellow engineers like me, I want to show you guys using my thermal camera to prove that it is the charging IC, that from experience I already know it's the charging IC. Okay, so I've already connected the power cable to the board. So the next thing, now you can see the supply is at 4 volts, 4 volt and 2.1 amps, 4 volt and 2.1 amps. So let's switch it on now. Let me power it. Okay, this board, this one is the ROF board. This one contains the baseband and the network chip. Okay, so this one is not the main issue. This one is, there's nothing wrong with this one. So it's this upper board. Okay, this upper board. So let me bridge it and see. Let me power it. Let me bridge the power key with ground, and you see that is the power IC. So from the thermal camera now, so I'm using a quick check imagery. Quick check. This is thermal imagery. This is thermal imagery. And this is quick check. So let's use quick check to see what is getting hot on the board. So you can see it is visible now. It is visible. So you can see there's no temperature anywhere so far. So let's power it. So I'll power it and show you very fast. So I want to bridge the power button now. It's located at this side. Now I've bridged it, so you can see. So let's flip the board over. Now you can see now. You can see the temperature measurement. I'll still do it one more time again for you to see. I was very slow, so I'll still do it one more time for you to see. You can see the temperature has already circulated the whole board. That's why you are seeing it like this. It has circulated. So let me reset. Okay, I'll reset it again. So once again, look at the board, look at the DC supply. So let me bridge it again. Let me bridge it. So I want to do one more time again. You can see it now. You can see. So that is the what? Charging IC. Alright, thanks guys.